Welcome back to my channel Easy Learning with Pragya. So today I'm going to take up a very important chapter in physics, that is light, reflection and refraction. So this title itself makes clear that I'm going to explain about reflection of light and refraction of light, two very important terms about light. So in this session I'm just going to discuss about reflection of light. But before we could start, let us first, try to differentiate these two terms, reflection and refraction. So let us, use simple words in order to differentiate what is reflection and what makes refraction different from reflection. So this is a opaque object, a shining surface. And then let us try to define reflection. Bouncing back of light when it is incident on a polished surface. So imagine this side is a polished surface. Now what is reflection? It is just a bouncing back of light. Once a ray is incident on this shining surface, it is a bouncing back of this light. It's a phenomenon called reflection. This is reflection. Just try to understand what is reflection. And then what is refraction? What makes us different from this? Let us see. So this is also a phenomenon of bending of light rays when passed from one medium to another. Say for example, you have two mediums over here. One is air and the other one is water. So the phenomenon of bending of light rays, this is a light ray, and once it passes from one medium to another medium, it started to bend. And this bending is a phenomenon called refraction. Just try to understand these two terms, that's it. And now we will learn a lot about reflection in this session. Just one second. So now let us learn something about laws of reflection. It is not LOSS laws, it is laws of reflection. I think you are already familiar with these laws of reflection from your previous classes. But let us have a quick recap, because these laws are very much discussed in this concept called reflection and refraction also. So this is a plane, this is a surface, a shining surface. And this ray which hits the surface is the incident ray. You all know that. And this is a ray called reflected ray. Now let's try to just draw a normal which is perpendicular to the surface. Now the first law of reflection states that angle of incidence is equal to angle of reflection. So now what is this angle of incidence? What is this angle of reflection? Let us try to understand. So the angle made by the incident ray with the normal is called angle of incidence. And similarly, the angle made by the reflected ray with the normal is called angle of reflection. So what is the first law stating? Angle of incidence is always equal to angle of reflection. So say for example, this angle of incidence is 30 degrees. Then the angle of reflection will also be 30 degrees. And this is exactly what the first law states. Now the second law states that the incident ray, normal and the reflected ray lie in the same plane. So what does this mean? Say for example, you have this to be the incident ray and you have this to be the reflected ray. And I don't have another hand to show my normal. Imagine you also have the normal. So the incident ray, normal and the reflected ray lie in the same plane. They lie in the same plane. It's not that we have a reflected ray like this, we have incident ray like this. It's not like that. It is in the same plane. And this is what is the second law of reflection states. The incident ray, normal and the reflected ray lie in the same plane. Just one second. Now let us look at some properties of the image formed by a plane mirror. A plane mirror. It's a mirror that we all have at our houses. So that is called a plane mirror. And let us look at some properties. The first property is the image formed is virtual, which means it cannot be captured on our screen. The second one is erect. Now say for example you have this object or a man, if you can consider, and this is a man, and it is same. It is in the same direction. It is up and this is also up. And this is property called erect. And the third one is that it is at the same distance. Now say for example this object is at a distance of 15 centimeters from the plane mirror. And the image obtained will also be of the same distance, 15 here, 15 there. So the image formed is at the same distance. Now it is laterally inverted. You must observe, right? Now if this is left, it appears to be right, and if it is right, it appears to be left, right? So this is laterally inverted. This is a property called laterally inverted. So these are the 4 properties of a plane mirror. Just one second. So far, we have been learning about plane mirrors and its properties. Now let us try to learn something about spherical mirrors, like concave and convex. You're all familiar with this name somewhere, like concave and convex. So let us first try to differentiate this concave and convex. So when the inner curved cave-like structure inside, when this part is reflecting, we call that as concave mirror. And when the outside bulged part is reflecting or shining surface, we call that as convex mirror. This is the difference, but both are considered to be spherical mirrors. Now, there are certain terms that you all have to remember and understand before we could proceed and learn more about these spherical mirrors. There are certain terms that we have to remember. Let us learn about those terms now. Let me take a concave mirror where inside part is shining. Now, this part is called pole. This is a point called pole, which is the center of the spherical mirror. So the center of the spherical mirror is called pole, which is denoted by capital P. Now this is called the principal axis. Now let us learn about the other terms that are involved. Now the spherical mirror is made from a hollow sphere. The spherical mirror is a part of this hollow mirror. So this is, see for example, this is like this. This part of this sphere is this spherical mirror. So this sphere will have a center. Now this center is called the center of curvature. Let us imagine the spherical mirror is made from a sphere, and that sphere will have a center which is called center of curvature. Now the other thing that you have to learn about this is concave mirrors are converging, but whereas convex mirrors are diverging in nature. So a point where all the light rays will either converge or diverge is called focus. It is actually called principal focus. So this is a point where all the light rays either diverge or converge. Now, and this sphere will also have something called radius. So this is called the radius. So this distance from the center of curvature to the pole is called radius of curvature, which is denoted by capital R. Now, this focus, the distance between pole and the focus is called focal length, which is denoted by small f. So the distance between pole and focus is called focal length, and the distance between pole and the center is called radius of curvature. And yeah, these are some important terms I think you have to know. Now, is there a relation between focal length and radius of curvature? Yes, there is a relation. That is, R is equal to 2f. So focal length is half of the radius of curvature, or radius of curvature is double of focal length. So I think this is actually a formula which you can use if they suddenly ask you to find the focal length of the spherical mirror, or they may even ask us to find the radius of the spherical mirror. In that case, you can use this formula R is equal to 2f, where focal length is half of the radius of curvature. So these are some important terms that you all should learn. Just one second. Now, there are certain important ray diagrams that you all should remember, which are very important. Now, the first ray diagram which is very important is that when a ray is passed or made parallel to the principal axis, as we know, this is pole, focus, center of curvature, and this is called the principal axis. So now, when a ray is parallel to the principal axis, then the reflected ray will pass through the focus. Will pass through the focus. So this is the thing you have to remember. And a similar thing happens in case of convex mirrors also. The second one is, I need to draw again. So this is a concave mirror again. You have the principal axis, pole, center of focus, and center of curvature. So the first thing says, when a ray is parallel, it should pass through the focus. Now vice versa. When a ray passes through the focus, where should the reflected ray pass? How should it move? The reflected ray should move in a parallel way to the principal axis. It is just vice versa. When a ray is parallel to the principal axis, the reflected ray should pass through the focus. And when a ray passes through the focus, then the reflected ray should move parallel to the principal axis. These are the two important ray diagrams, and the same applies for convex mirrors also. The third one is, again a convex mirror. When a ray passes through the center of curvature, this is the center of curvature. When a ray passes through the center of curvature, the reflected ray will also move in the same direction. This is the third important ray diagram, which even applies for the convex mirrors. Why do you think so? This is because, what is this? This is the center of a sphere from which the spherical mirror has been made. So now, this is radius. Now radius, this is 90 degrees. So whenever it is 90 degrees, it is considered to be normal. So the incident ray is directly towards the normal. Now what is the angle formed? What is the angle of incidence? It is 0 degrees. And as per the laws of reflection, angle of incidence is always equal to angle of reflection. So when incident ray is 0 degrees, definitely angle of reflection should also be 0 degrees. So that is the reason why it moves in the same direction. And this applies for convex mirrors also. And the fourth important ray diagram is it is just applying the law of reflection. Angle of incidence is equal to angle of reflection. This is an fourth important ray diagram, which even applies for convex mirror also. So these are the things that I thought of explaining in today's session, and the next video will explain about things. You have certain things like if an object is placed over here, where will the image be formed? If the object is placed at the center of curvature, where will the image be formed? In case of concave and convex lenses, convex mirrors would be explained in the next session. And please do watch my videos, and if you guys are anyway connected, don't forget to subscribe my channel. Thank you.